Hello, everyone. Welcome to the EasyPower Thursday webinar series. My name is Jim Chastain. I'm an applications engineer at EasyPower and the host for today's webinar. And before we introduce our guest speaker, I'd like to make a couple of announcements. First of all, we're recording the presentation and it will be posted to our website for viewing later, along with a copy of the slides that you can download from the same location as well. Now, as our practice, before we start the presentation, we'd like to run a couple poll questions to get some perspective on the audience's position on the topic. And so if you would please contribute by indicating your responses on the poll question. So the first is, what are your expectations from the day's presentation? Basically, what do you hope to get out of the time you spend with us? No obligation, no liability, just strictly trying to understand your perspective, because we do have an authority on the topic and we expect him to be able to amplify areas that are of greater interest. This is truly an international event. Our guest speaker is joining us from Italy, so we have a well-rounded presentation. So it looks like we have a quorum on this poll question. Here's how folks have weighed in on it. And we do appreciate your indicating your preference or your choices. And it looks like we're all in the same vein. And so the second question is, what are the main challenges you face when you're dealing with a new project with a generator involved? So again, kind of tell us what you think is your biggest concern or biggest motivating factor. And frankly, there's a lot of interest in this topic because it's something we find a lot in working with the EasyPower simulation, with people having to deal with the generator protection and the modeling thereof. So let's get a few more participating here. We're not quite to a quorum. Let's open this for another 10 seconds. And here's how folks have weighed in on this. Looks like we have a majority wanting to know the basic recommendations, which I think we're in the right position to provide. So without further ado, I'd like to hand the presentation over to Andre, who's an expert engineer from ABB. And as I indicated, he's coming to us live from Italy. So Andre, you have the podium.
Yeah, thank you, Jim. I really appreciate your introduction. Thank you for handing over. I'm presenting myself now and also showing myself now. This is Andrea. Hi, everybody. Thanks for this opportunity. For me, it's really, really important to have the chance to introduce you to the technical requirement, highly demanding requirement of such application, such really dedicated application, and what we as ABB can provide you with in terms of solution, in terms of support. We are not here just to present product. We are here to understand what are the issues, what are the challenges of the users in this kind of application, and what we can do actually to support. And this is our target now, to present our answer to all those technical, really demanding technical requirement of coming from the typical generator application. The generator application is the one, as we all know, that is including typically a single line diagram that is simplified, as you can see here, that in general is composed of very, very, let me say, important, crucial, expensive assets like the generator, like the transformer, and many others. All these assets must be necessarily protected, because the main aim of a device that is installed to protect is exactly to offer, again, the highest level of protection. But why we are talking about a level of protection? Why we are talking about reliability in protection? Because we need to assure the highest level protection against events of fault, of short circuit, that can unfortunately happen in a plant like this. And each and every kind of such event is characterized by really, really peculiar, and I would say really also challenging and severe electrical parameters. We all know that the number of the unfortunate events of short circuit events that can happen in a generator plant are more than one. And again, each of them is characterized by a specific set of electrical parameters that are much, much more severe than what we are used to see in a typical distribution network, in a typical distribution application. Namely, these possible events of fault are the system source fed fault, that is basically characterized by that is basically identifying the short circuit where the current is mainly supplied by the network. So basically the circuit breaker, the device that we have installed in order to protect the assets against this event is, let me say, must be able to withstand to a short circuit current mainly fed by the system. Another one, as we all know, is the generator source fed fault. The generator source fed fault is the one where the short circuit current, again, as the name indicates, is fed mainly by the generator. And then the out of phase. And what I want to highlight after this very, very quick technical introduction of the pure technical challenges of such application, well, what I want to highlight is that whenever we face with our device such undesired short circuit events, we need to assure the highest level of reliability and protection. Why? Because for instance, the system fed fault or the generator fed fault are characterized by very high, significantly high degree of asymmetry or short circuit peak of current. All these characteristics must be the characteristics of a very, very good solution installed to protect. This is exactly what we want to target, what we want to present, because from us must come an answer, a solution to all these challenges. Challenges that are so evident and significant and severe that from the normative perspective, a totally new approach was needed. Also from the normative point of view, we needed in 2015 a sort of unique global reference, globally accepted, replacing everything normatively was present and taken as a reference in the market before, in order to give a precise indication, a precise answer to all these questions, to all these technical requirements. The answer from the committee, the IEEE committee, was the so-called dual logo standard, the IEEE/IEEE 62271-37-13. The normative, the standard that is now globally accepted, taken as a reference for all those manufacturers, players in the market of the generator circuit breakers, because we need to have the strongest reference, normatively talking, in order to guarantee what I mentioned before as the highest level of reliability against all the possible short-circuit undesired events that can happen in such dedicated application in order to protect not only the generators, but also all the other assets connected to this network. This is exactly what we want to aim with our products and with our knowledge and with our support and experience. But the technical aspects are not the only one that we want to address, that we want to answer to. Every time a user is called to manage a project where a generator, one or more generators are installed, well, in that moment, we need to provide not only the highest level of protection, as I mentioned, as I described, but also the easiest level of installation. The ease of installation, specifically where all those projects have the need of space saving and see it as a premium. Well, also we need to assure that the solution, the package that we are installing, has the lowest level of impact, the lowest impact in the existing installation or in the new installation. What we can do now, as we will see, is offer a solution that can assure the highest performances against the short circuit, having at the same time the most optimized footprint. However, this is not only a matter of product, as I said initially. We need to talk also about the support, because we have a lot of solutions, a lot of products that we can provide you, we can offer you, but sometimes it is also difficult to select the right rating to install. From this point of view, the normative, the standard offers also a sort of guideline. And there are a lot of articles, papers, experiences, analysis available in order to do so. We, as ABB, can now offer a complete package of experience. With our breakers, with our knowledge, with our support, we can guide you since the beginning, since the starting phase of the project, by helping you in the selection of the right breaker for your specific plant, for your specific project. We all know that each generator plant has a specific set of characteristics, specific set of data. The power level, the voltage, the network voltage, the rated voltage, the rated current in certain points of the SLD of the single line diagram, but also the length of the cable, the short circuit level in certain points. All these data can be analyzed by our experts, by the tools that we have, and by thanks to the experience and the knowledge that we have built during the last years in this kind of really dedicated and, let me say, demanding application. Then what we can do is offer a complete product family, starting from the highest level of braking capability for the system source voltage, as we will see, together with the opportunity for you to transmit us the characteristics, few parameters characterizing the plant of your interest. And we can use them and take them as an input for our softwares, for our experience and calculation models, in order to give you as an output, as a support, the specific rating that you need to install in each part of the SLD, of the single line diagram of the plant, in order to assure you the highest level of protection against the short circuit events that can happen in each and every sensitive points, crucial points of your plant. This is exactly what we can do now, and what we want to offer you in terms of complete package of experience, as I like to say, an experience for you using our generator circuit breaker products. A portfolio that is composed of many ratings specifically selected in order to answer to all possible questions, requirements. From the highest level of short circuit, that is in our case 63 kA, short circuit from fed by the system. So in case of system source fed fault, we can offer the VD4G63. The VD4G63 has the footprint of a typical breaker at 63 kA with the typical dimension means in-out distance and phase distance of a corresponding distribution breaker. From the outside, from the dimensional point of view, the footprint is the same. However, the performances represent a quantum leap compared to a standard distribution breaker, because we can reach levels of short circuit with a very, very high degree of asymmetry. In case of generator source fault, according to the standard, up to 130%. A typical distribution plant can see a short circuit of 30 or corresponding to 30 or 40% or 50% maximum. In a generator plant, due to the presence of such specific kind of machines and due to the law of the physics and electrotechnics, we can really reach higher, much higher level of degree of asymmetry that we can really face and withstand to, thanks to our products. 130% in case of generator source fault up to 37 kA and 50 kA generator source fault breaking capability up to 110% means that the phenomenon of the current zero is very, very significant, but despite this, our breakers can really offer you, however, anyway, the highest level of protection. Against the system source fault, short circuit events, we can offer 63 kA up to 75% of degree of asymmetry. A very, very important, significant value that gives an idea of how powerful and how performing are the breakers of our generator circuit breakers portfolio. The VD4G63 is not the only one. The only one breaker clearly in our portfolio. This is available, just a few words in order to give you the full overview of what we can offer in terms of variants or versions of our breaker. We can offer this in fixed or withdrawable version, and in case a withdrawable version is needed, also we can offer a complete solution with the corresponding unigear panel. Together with the breaker, you can really benefit of a complete solution, completely interchangeable from the dimensional point of view with a typical footprint of a standard distribution panel, but assuring you the highest performances possible for such level of power. Level of power that can go up to 100 MVA, because we are talking about a product at 15 kV, 4,000 amps rated current. Coming back to the lower, let me say, level of breaking capability, we have VD4G50. Dimensionally, it can remind the above mentioned VD4G63 and also the corresponding footprint of a typical distribution breaker, because we want really a benefit, the advantage to have the minimum impact in your installation. If you have a footprint, a typical footprint, because you were using a standard distribution breaker before, now you can see directly the benefit of replacing this with this new breaker according to the latest standard, tested and decided according to the latest standard for generator circuit breakers, completely interchangeable with a corresponding typical distribution breaker. The same rule then is applicable to the VD4G50. VD4G50 that can offer, as the name says, 50 kA for system fed fault braking capability up to 75% of degree of asymmetry, and 50 kA, up to 50 kA in case of generator source fault. A very, very interesting and significant value, because we can really offer with an optimized footprint the protection against very, very significantly high levels of braking of short circuit. This breaker is also available as the previous one in withdrawable execution, exactly as all the other breakers in our portfolio. And also this can be completed by offering you the full package, the full solution, including also the panel, the Unigear ZS1 panel. If you are searching for an even more optimized breaker for an intermediate level of power up to 50, typically 50 MVA at 15 kA, we can even answer to your needs by offering you the WD4G 50/25. The WD4G 50/25 is the best fitting product generator circuit breaker for all those power plants up to typically 50 MVA, as I said, requiring, let me say, a more optimized dimension of the solution of the product. Means a smaller phase distance up to 210 millimeters. Also, this product is, even with this more efficient, more optimized footprint, can offer the same high level of protection against the short circuit, both in case of system source fault, up to 50 kA, 75% of degree of asymmetry, and up to 25 kA in case of generator source fault, up to 130% of degree of asymmetry. A very huge level of DC component, showing, as you may imagine, directly the phenomenon of the missing current zero for long time, something that we can manage. We can manage easily thanks to the fact that this very performing breaker is tested for the most demanding requirements according to the dual logo. 40 kA/25 kA for this alternative solution, complete up to 100 MVA power level at 15 kV, WD4G 40/25. This complete product up to 40 kA in system FET fault is able to offer the highest level, the highest reliability and protection in both withdrawable and fixed execution for all the possible platform of enclosures and panels from ABB. All this product together with all the others can be offered for an advanced level of safety if required, even in case on request, even in case it is requested demotorization on the truck. With the 4G25, it is the best solution, the most optimized solution for all those power levels where the power level is up to 30 MVA typically. Thank you for your attention. Now let's have some few minutes for the questions.
Andre, let me share with you the list. I only see one right now. You should be able to see the question list on the control box. So Habib is asking, what's the selecting parameter if you have to supply, or if you have multiple generators on a system?
Sorry, Jim, I was, trying to see the questions, but I cannot. Can you please repeat, please? Thank you.
So Habib is asking, what is the selecting parameter if you're using multiple generators?
Oh, well, this is interesting. In this case, we are able to analyze the complete single line diagram. You just need to send, well, exactly as it is, let me say, reasonable, the schematic of the plant, including all these generators. We are able to identify according to the schematic, according to few other parameters like the characteristic data sheet of the generators typically, and the data sheet of the other elements installed in the plant, we are able to understand first what is the, let me say, the worst condition of fault. Means the worst case scenario of fault, and then we can analyze according to this worst case scenario of fault what is the right solution to be installed, means what is the right rating to be installed.
So that actually, I think, answers a similar question. How about if we have multiple generators on the same bus bar? So you're talking the total available current if you have multiple generators faulting at the same time. Is that, yeah, that makes sense.
Absolutely correct. Absolutely correct. We need to evaluate specifically also that point where all the contributions from all the generators are coming, and according to this, we need to select also in that point the right breaker to be installed. Sure. And typically, according to my experience, due to the fact that the contribution of all generators is a very significant, important degree of asymmetry coming from all the machines, we need, however, a generator circuit breaker. So in this case, surely we recommend from our side an analysis to support you the best. Thank you.
Okay. So another question is, can you explain why generator fed faults on the line side of the generator breaker and system fed faults are on the line side of the breaker? So generator fed faults are on the load side and system fed faults are on the line side.
This is absolutely correct. This is absolutely correct. This is a distinction that is needed in order to identify what I, let me say, indicated as a possible events of short circuit. That is depending basically on the point where this event happens. And according to this, the normative, the standard prescribes specifically the performances, specifically characteristics that the device, means the solution, the breaker, the circuit breaker, should offer and should assure in order to fully protect all the assets in the network, not only the generator. Why there is this distinction? Because mentioning just these two types of fault, each of them are characterized mainly by a specific set of technical electrical parameters. Mainly, just to give you some some very quick reference, we are talking about very high degree of asymmetry, as you may imagine. It could be reasonable considering the characteristics of the machine, a very high degree of asymmetry in case of generator source fault, a very high peak, and a very high, let me say, specifically high, very severe condition of TRV in case of system, also in case of generators. There are characteristics that are quite peculiar for each kind of event, and we need to test the breaker, the generator circuit breaker, according to all these parameters.
Ali is asking, do you offer arc-resistant switchgear, and if so, what types?
We were waiting for this question, because I know that also it is important, let me say, the panel and the characteristics of the panel, specifically in some markets, also in for instance in the ANSI market. That's the reason why I left a dedicated slot, a dedicated session that will take a few minutes to the solution that are dedicated specifically for the ANSI market. We have the corresponding products for the, let me say, for typical ANSI market, means for typically ANSI arrangement with the panel with certain characteristics according to your needs. Needs that can be deeply analyzed. However, just to give you a few hints, we have ADVAC G63/50, that is the corresponding of the VD4G 63, dedicated for the ANSI panel. ANSI panel from ABB that can offer you, as you can see in this case, it is called Safe Gear HD, that can offer you specific characteristics that I will share with you, that you will, let me say, be able to see as an attachment to this presentation later on. Coming to the, let me say, to the second product in order of rating of our ANSI portfolio in terms of generator circuit breakers, we have ADVAC G50. ADVAC G50 is the corresponding ADVAC corresponding to the VD4G50 for the ANSI arrangement, means dedicated with its withdrawable execution to the to our ANSI switch gears, namely Advanced, Safe Gear, or Safe Gear HD, according, again, as I said, to each specific need that I can share with you with some material later on, and ADVAC G40. ADVAC G40, that is corresponding to the VD4G40, but with the completion parts, with the adaptations needed in order to perfectly fit in typically ANSI solutions like our advanced or safe gear panels.
And so does that make it more arc resistant or just applicable in arc applications? I think we lost your audio.
I'm really sorry. Sorry, Jim. Typically depends on the type of panels. We can offer and give a direct indication of what can be offered in terms of arc resistance according to the specific requirements.
Got it. That looks like the last of the questions. Thank you very much for the presentation, and we'll forward the list. If anything that you want to follow up on via email, we'll forward that list after the presentation is completed.
Yeah, absolutely, Jim. Just to give my references together with the material, I will share with you, as I said, some more details regarding our solutions in terms of arc resistance, that can offer arc resistance, and also my references. You can write me an email or contact me via phone. I'm fully available, me together with our marketing colleagues, in order to support you, again, not only with products, but also with our experience and with our knowledge. Thank you.
Thank you. Talk to you later.
Thank you.